Hi there. So in this video, I'm going to quickly derive the quadratic formula. So lots of times people ask teachers how we get this ugly looking expression just from having ax squared plus bx plus c equals 0, right? Because this is the value of our function for any given value x, and we know we're looking for the x-intercept, so it's going to equal 0. But we say, well, how can we figure all this stuff out just from knowing this one equation? And the answer they typically get is that it's the super long derivation that no high school student can do. You need calculus to figure it out, blah, blah, blah. And that is just not true, right? The stuff that they teach you in high school or the stuff that you can learn yourself online is totally enough information to be able to figure out the quadratic formula, right? So my last video was on completing the square, and we're going to need to know how to complete the square if we want to derive this. So if you haven't seen my last video, just go check that out. Might be kind of useful, and if not, if you've already seen it, then let's just dive right into it here. So we know that ax squared plus bx plus c equals 0, and in math, all we're doing is we're taking one thing and we're using it to figure out something else. So even though it looks kind of weird, these two things mean the exact same thing. They're solving for different things, but from this equation, we can derive this and using nothing else. Okay, so that's kind of cool. So if we complete the square, we know we have to factor out this coefficient a. So if we factor out a, we know we have x squared here, but we multiply a and we want to get this bx back. So if we add b times x, but if we divide it by a, right, a times b over ax will just give us this bx back, so that's what we want. So we're going to add b over ax, right, and when we complete the square, we always leave this plus c on the outside, this constant, this number. Okay, so this c is unharmed, it's untouched. Okay, and when we complete the square, we always take the second term inside the brackets, right? Divide it by 2. Or sorry, let's see. We keep this b over a times x, right? And then we're always adding the coefficient on the second term, b over a, and we're dividing by 2. So this is b over 2a. And remember, we're squaring it. So we keep these two things the same, the first two terms. And then the terms that we add and subtract, right? We have to subtract it now as well to keep the function the same value. Okay, the things we add and subtract are the coefficient on the second term in the bracket divided by 2 squared. So b over 2a squared. And we have this plus c, and that equals 0. So it's kind of a long line there. Okay, now if we want to bring this last term out, right, because that's when we complete the square, that's kind of the objective. Okay, we have to multiply it by a. So first, if we simplify, right, x squared plus b over ax. This b over 2a squared, this squared is distributing into everything inside the bracket. So it's going to be plus b squared over 4a squared, right, minus b squared over 4a squared. So we're squaring b, we're squaring 2, and we're squaring a, right? And we got this plus c on the outside equals 0. Okay, so now we want to bring that last term out. We can multiply it by a. So we have a times x squared plus b over ax plus b squared over 4a squared. So we want to keep all these inside still. But remember, we multiplied the a and then negative b squared over 4a squared. So if we multiply b squared over 4a squared by a, that just means that we're losing an a on the bottom. So this is going to be minus b squared over 4a instead of 4a squared plus c equals 0. Okay. So lots of times when people see the derivation of this, they just kind of follow the steps and don't really know like what we're actually doing. What we're doing is we're trying to solve for x. So we see x twice here. Let's try and factor this out. That's the whole point of completing the square. So we can make this a square by having x plus the coefficient on the second term inside divided by 2, right? So x plus b over 2a squared. So these two things are exactly the same. That's the benefit of completing the square. That's why we kind of did all this. right? Minus b squared over 4a plus c equals 0. Okay, and like I said, we're solving for x, so everything that doesn't have an x, let's try and get it onto this other side here. Okay, so we can subtract c and add b squared over 4a on both sides, right? Because then those will cancel, and we have plus b squared over 4a minus c. So I'm just going to rewrite this here. A times x plus b over 2a, right? We have nothing left on the left side, equals b squared over 4a that we added on both sides, minus the c that we subtracted on both sides, right? So we're trying to still get this x on its own. It's kind of embedded, I forgot this square root, or this square sign here. So it's kind of embedded within the brackets. What we want to do is we want to divide both sides by a, so that this a cancels. So we divide both sides by a here. So now all that we're left with is x plus b over 2a, right? That's all squared, remember? So we got to kind of divide this into two fractions. So we have b squared over 4a minus c over a. So b squared over 4a divided by a, well, we're just adding an a on the bottom. So it's going to be b squared over 4a squared minus c divided by a, which is just c over a. We can't really reduce that anymore. Okay, next thing we want to do is we want to combine these two fractions to make it all over the common denominator. So if we want to combine, if we want to subtract fractions, we got to have a common denominator. That's going to be 4a squared, right? So if we multiply the top and bottom here by 4a, see when we multiply these, we're going to get 4a squared. Okay, and when we multiply these, we're going to get 4ac. So when we kind of subtract these together, the left is still x plus b over 2a squared. That's going to equal the numerator of our term on the left, b squared, minus the numerator of our term on the right, which is 4ac, divided by our common denominator, right, which is 4a squared. So this expression here is the same as this expression. It's just kind of mashed together to make it a bit more simple. We simplified it. We subtracted the fractions and made them one, right? So now if we have something squared and we want to find the x that's on the inside, we want to get rid of that square, right? We want to square root the square. So square rooting a square, those are inverse operations, so it cancels and we're just left with whatever's in the inside. Right, because before we were squaring this, but we square rooted it, so now it's gone. Okay. And on the right side, we have to square root it. Anytime we voluntarily just kind of add a square root on both sides, we have to add this plus or minus here. So it's going to be plus or minus the square root of b squared minus 4ac, right, divided by the square root of 4a squared. So the square root of 4 is 2, and the square root of a squared is just a. So this is probably looking pretty familiar now. And all we have to do is we want to get x on its own, so we subtract b over 2a on both sides. So we subtract b over 2a. Well, the square root of b squared minus 4ac over 2a minus b over 2a, well, 2a is the denominator for both of them. So we don't have to change much. All we have to do is just add this minus b on both sides. So b squared minus 4ac, right? And we added this minus b, and all of this is over 2a. And all the quadratic formula does is it rearranged this by just bringing the negative b out front. So x is equal to negative b plus or minus the square root of, b squared minus 4ac all over 2a. So for any given quadratic equation, you can plug in your a, b, and c values to figure out where your x-intercepts are, right? Just from knowing what the equation is. So that's pretty cool. We derived all this just from having ax squared plus bx plus c equals 0. So That's the derivation. Hope this makes sense, and I'll see you in my next video.